Hello, my name is Tomasz Żyjewski, and the topic of this presentation is updates of Yocto-based projects, effective strategies for ongoing maintenance. Okay, so at the beginning, a couple words about me. So once again, my name is Tomasz Żyjewski. I'm working at 3M over 4 years. And this is for now like my whole commercial career. Most of the time I work on integration of update systems and doing the operating systems creation for embedded devices using Yocto project. On those systems we try to focus on system security, so I know, for example, we try to integrate the secure boot on some kind of ARM-based platforms. Next, couple words about 3M. We are a company located in Gdańsk, which is a city from Poland, the north of Poland. Our work focused on core boot, UEFI, and also we are the Yocto participants since the 2019. And yeah, let's now go through the agenda. So in this presentation, I would like to, the goal of the whole presentation is to present the some high level, let's say, sees on the projects that can be built using the Yocto. So we want to, at the beginning, show the project lifecycle, what is at the beginning of every project, how we need to plan our development, then how we will build it, test it, deploy, maintenance, and at the beginning and at the end update. Now I will say a couple words of the project components, so the documentation, build environment, etc. Then I will talk about the update strategy, so what do you need to remember when we want to update some Yocto-based projects, and when is the best time to do so. Then I will go strictly to the update thing. So now, firstly I will talk about how to perform update, what we need to remember about, so how to prepare our build environment for the Yocto release that we want to use, how we define the layers that we use in any project. So we call some layers like the external ones and the custom ones, and I will talk about it a little bit later. Then I will go through a couple of examples of build troubleshooting on different phases of starting the platform. So on the bootloader side, kernel, some default application and some custom application that are always integrated in various projects. At the end, I will talk about the update verification, so how we can check that we provide the same system but with the updated components. And at the end, there will be summary. So yeah, let's explore the project lifecycle and emphasize the crucial role of the updates. So at the beginning of every project, we may have a phase called initiation. So there we want to gather project ideas and the requirements that should be fulfilled for our project to work as it should. Then we can have something called planning. So in the planning phase, we'll take those ideas and define the scope, the objectives, and the strict deliverables that need to be provided for our project to be successful. Then we have the development phase. So we need to prepare our build environment, and we need to configure and build our Yocto project, our Yocto-based project. Next, we have the testing phase and the time when we need to provide a documentation for any given feature that is inside our image. After that, there is like the deployment phase. So we need to think about how to deploy our project to the devices that we want to run, that we want to use to run it. Then is a phase, the maintenance phase. So probably there is a couple months break, let's say break, to just monitor if there is some problem with our project. So maybe add some bug fixing or think about next release of something that we provide. And if we gather a couple of those problems, then it's the phase for update our whole project that we previously developed. So now we can switch to the project components. So at the beginning, when we want to plan our project, we'll need to prepare and create the architecture documentation. So that would be the documentation that describes the whole hardware that we'll use, software, and how they are connected. Then we'll have the feature documentation. So this is the most important part of any given project. So because it will tell us what we want to provide within our image and how it should work. Next, there is the build environment. If we are using Yocto project, then it needs to just fulfill the documentation that is available up there. And also it is useful when we can somehow automate preparing it. Next we have tests. So there is the same thing for the automation. The best sets of tests are those that can be run without human interfacing. And we need to provide we need to cover all the functionalities with our tests, so we can always present that everything is working as it should. And next we have last component with the CI/CD pipelines that we can use also both for building our image and for testing it. If those are prepared properly, that significantly speed up our whole build timing. Okay, and here you can see how those phases in project lifecycle and project components can be matched together. So if we talk about the initiation, then we'll probably provide the architecture documentation. In planning, we can start thinking about what exactly features we want to have and start to sketch some drafts of the feature documentation. The development has the build environment. We need to think about how to prepare it, how to maybe share with our colleagues that will be working with us on that project. Next, we have the testing and documentation. So here we are preparing tests and finishing the feature documentation, so we can always prove that something is working as it should. And the deployment phase, where setting up correctly the pipelines help us to speed up the whole process. And all of those phases, so from initiation to deployment, needs our maintenance through whole project, and also at the end needs to be updated when something changes in our projects. So now let's move to the update strategy. So yeah, during the update we need to remember that every part of our project needs to be updated. So it is not like we just focused on changing the Yocto release, finishing the build and thinking that the whole work is done, because it is not. We need to also look at the testing, at the documentation and other components. Also, when we are updating our project, we need to think how our end users are using it. So we need to think how they will deploy the updated images on their platforms. We can have here two scenarios. We can have some devices in the field, let's say, and in that situation, we need also have some update system in our whole project that will allow them to just quickly update their devices to the latest image without some kind of downtime, and this is how we can reduce any kind of losses that they can have in the time that the devices are not functional. And in other cases, we can, for example, provide some BSPs only for the end users that they just use to build some kind of images for their own. In those cases, we don't need to worry about the deployment of our end project, and we just need to update the metadata and make sure that they are functioning. Okay, and we also have a couple of ideas when the update should be taking place. So we can just sync with the Yocto release cycle. So we can try to update our project every, I believe, 6 months when there is the minor update released. Or we can just switch to the LTS version, as we heard that should be supported for 4 years now. So just use that and had like patch updates every couple of months. The next thing is that we can use the CVE checks and security reports. So we can add some BB class to our project to constantly check if there are some security problems that our project needs to have fixed. And based on information from that report, we can decide if updates needs to be done now or can be done later. And other scenarios that the feature set requirements, so we can gather like bunch of features that we want to add to our project and then prepare the update so our project remains competitive in the market. Okay, so now let's dive into process of performing updates in Yocto-based projects. When we're talking only on updating the metadata, we need to remember about 3 things. We need to be sure that our build environment is prepared well for the given Yocto release that we'll be using. Then we'll need to update the external layers, which I will explain a little bit later. Next, we'll update the custom layers, so the layers that we use to provide any given customization and some end-user applications. Later I will also provide some examples of troubleshooting, which comes up on our side when we work on some project with the Raspberry Pis, the IMX platforms or rock chip ones. Okay, so let's start from the build environment preparation. So every time we want to switch to the new Yocto project release, we need to see the section called the build host packages, which can be found in Mega Manual. There should be a list of dependencies that we need to fulfill in our build environment to be able to build our project within the latest release. We need to remember also, as always, when we're using the documentation, we need to remember to use the correct release and correct version of that documentation. So having those information, we can go to preparing a build environment. As I said earlier, it is helpful when we can have some reproducible, let's say, build environment that we can share with our colleagues that are working with us. So for that, we can use, for example, Ansible to prepare such environment, or maybe even better, use some containerized image for that. There are a couple of already available. We personally using the one provided by CAS. but also there is one from the IMX called the IMX Docker that also should be okay. So if we are using some containerized image provided by some, let's say, third party, probably we just don't need to worry about checking the dependencies on given release, because that probably already is tested by the community. So if we have the build environment, then we need to switch to our build configuration files, which should be the localconf and bblayersconf. We should check if there are some additional changes that need to be applied for the latest release. For that, we can look at the migration guides, which are released for every given Yocto release. Probably when we are switching from some older releases, then we'll need to check the couple of migration guides to make sure that we are not missing anything. Yeah, that bit. Okay, so the external layers. In our understanding, the project that are built with Yocto and using some meta layers can be, let's say, divided into kind of layers. We have our custom layer, in which we provide any custom applications and any changes to the configuration, for example. And there are a bunch of external layers that we use as sources of, let's say, functionalities that we want to use in our project. And that's why we want to follow the rule to never modify the POC layer, like never ever. That is that comes from the documentation. And what we do here, we even expanded to other layers, so we never ever want to make any changes in any given external layer that we are using in our project, because that way it is easier for us to maintenance what is going on with the, let's say, configuration changes that we need to provide and which comes from the requirements for a given project. As for the work that we need to do with external layers while updating our Yocto project, Yocto-based project, is that we need to set up to some kind of revision of those. So probably any one of them has the branching name for all of the Yocto releases. So when we are switching to Kirkstone, probably all of them have some branch named Kirkstone, and we just need to choose the revision that is working for us, and that probably would be end of the work with the external layers. Most changes will be done in our custom layer, and that's why, as I said, it is easier for us to maintenance that. So when we starting the update in those custom layers, there are a couple of tasks that are done with every occasion. So for sure we need to update our layer series compat variable to make sure that our layer will be compatible with the release that we are switching to. Without that, the build cannot be started. Then we will just need to check through the BP appends files that we provide there. For example, maybe in the past we create some BP append that is only applying to specific version, and now the version of that package is increasing, so our BP append may not work anymore. We may have some patches that could be already upstreamed, so those could be removed from our custom layer. Next, we will need to go through the syntax and variables and check if they changed, and if we need to make some work there to be sure that the outcome of the build will be the same as before the update. Yeah. And as earlier, we can check the migration guides in case that something is not working as it was working before, or working in the strange way. Okay, so now let's go through the build troubleshooting. On the High level, I think we can split every operating system booting into a couple pieces, and I think those pieces could be like the bootloader part, the kernel with the device tree, and the root file system, which provides some custom and default application, and what is more important, provides some functionalities in our project. And in any of those parts, there may be some problems while we are updating to the new version. Yeah, so in the bootloader, we can have some configuration switches. The environment variables may not work as they were working previously. The boot script may not work also. In the kernel device tree, we also may have some problems with the configuration and maybe drivers. With the application, we need to check the configuration of them, if they compile properly and are installed as they should. And about functionalities, we just need to test them using our test suits prepared previously, and well, probably test them as long as all of them are passed. Okay, so yeah, as I said, we have some, let's say, real-life examples that we have in our previous work when we were updating a couple of projects to the Kirkstone release. And we'll discuss the following problems. So there is some changes in the bootloaders and kernels that we need to done on some IMX-based platforms. Sometimes some configurations changes in the POCI layer, so the changes that we provide in our BB appends were not applied properly. The other times we need to just provide some modification to the source code of our custom applications because something was changed in the image that we provide. And at the end, also the testing, the tests need to be changed in one of the projects, so I will also talk about that. Okay, so let's start with the bootloader. The problems that we may have here are some faulty boot scripts and maybe problems with rebasing the custom drivers and configurations. Also, there may be problems with the Yocto recipe itself, but to be honest, most of the time when we manage to manually config everything, then switching that to Yocto is not really painful. So there may be a problem with boot scripts where the device that we're using to boot our platform may change. But as I show here, also there was a boot script kind of problem where the environment variable that was providing the address of our boot script was not fulfilled properly, and that's why our platform didn't boot correctly. There are problems with the dev configuration. Sometimes just the configuration name was changed and they are not applied properly, as in the first example. In the second example, there was a situation where in previous releases of the bootloader, there was the same problem with the memory, so there was not enough memory defined for in SPL, but there was no information about that in the system. After update, the error was printed in the boot logs, so we need to fix that. In the kernel, we have the similar situation as with the bootloader, but here often we can work with the device tree, as we are probably using more peripherals in the Linux side. So yeah, this is the first example with the dev config that one of our users were using the GPL file system configuration, and to be able to enable it, we need to find some additional configs. In this situation, it was the config expert one, just to correctly enable what the client wants. Next, the problem with device tree. So the first one is that there was some change in the DTSI files provided by Linux kernel that were used by our custom device tree file. And because of those changes, the clocks were not properly assigned to the device, so it doesn't work well, and we need to debug that and at the end fixed. With the SI, yeah, well, exactly, that was the problem with the SI device. Okay, so now we have the default applications problems. So here, when we talk about the default application, we talk about the application that for what we didn't provide the custom code, the source code, and those are the ones that we want to just provide from other external layers. But sometimes we need to change some configuration of them. So there is an example when the package config name changed from the SSL through OpenSSL. We built our image, it boots, and everything looks like it is working okay, but through the later testing, it comes out that the given package were not having the OpenSSL configuration, so we need to add that. The another example is from the one package used from the one of the external layers. So the recipe was not built correctly, even that we didn't provide any kind of custom changes to that. So that was kind of strange issue, I would say, but in the end, it turns out that some header files were not properly found by the in the compilation time phase. So we prepare a solution for that, just to include correct headers. And as always, in those kind of situations, we just should create an issue in properly layer and try to resolve the problem. So it was what we done. Next, we have the custom application example, in which we were using in one of the projects we were using the Qt5. After the update to the Kirkstone, it was changed to the Qt6, and our application was not compatible with that. So we need to take our source code, check what was not working correctly, and make proper changes. And this is what we done, and after that we were able to compile the application and provide the functionality that should be provided. Okay, so here's time for verification of our update. So as I said, just building the image may not be enough. We need to make sure that the functionalities are the same before and after the update. The essential part here is the documentation and testing, because those can tell us if we update everything correctly. Yes, so and also after we have some bootable image, then there is that part where the most important and tedious work is need to be done, because we need to start iteration of our testing, improvements, rebuilds, and retesting, just to make sure that everything is working. And sometimes the test suites also need to be updated, because something is behaving a little bit different than before the updates. So those are okay. Yeah. Okay, so yeah, most of the time we are using some logs just to verify if everything is working well. So sometimes there may be problems with the path changing or some outputs, or let's say we are using some default applications that are no longer logging to the system as they were logging before. So we need to look also at our testing to make sure that they look what they should look for. Okay, so as you can see, performing just the Yocto-based project update is not the easy thing. We need to think about a lot of stuff. We need to think how to update it, how to prepare the build environment, and how to test it properly. Every project component that I mentioned is important, not as I said just before. So in the validation phase, The documentation and testing are important, and the working CI/CD pipelines helps a lot when we are doing those iteration cycles. And about the timing of the update, we can just sync with the Yocto release cycle, or we can just check with the CVE reports to make a decision where the update should be done. Here is some information about us, the resources I used, and thank you very much.